All right. Hello, my name is Dane Whitmer. For those that have joined recently, I am the AZ Water Distribution Committee Chair, and we have brought these presentations to you and hope to expand your understandings and your experiences, as well as an opportunity to gain your PDHs for your operator certificates or whatever professional organization you may need them for. Ricky, do you have anything that needs to be brought up, and you want to introduce yourself as well?
Yeah, I'm Ricky Holston with Sunrise. I'm the webmaster for the distribution committee. Just want to thank everybody for attending today's webinar. Should be a good topic about what do's and don'ts of your maintaining your tank. Be sure to look out. We're trying to do this once a month on the third Wednesday of the month, or third Thursday of the month, excuse me. So be looking out for other ones to attend. Catch up on your CECs as much as you can without having to leave the office. And then when the presentation's over, we'll have next month's topic ready to go. But otherwise, I think Mark will kick it off.
Thank you. Appreciate the opportunity to get to speak to all of you. For those of you that actually can see me on Zoom personally, I'm sorry I'm not better looking, but for those of you that just see the presentation screen, you're probably lucky. So a little bit about myself. First of all, my name, as just introduced, Mark Moore. I've been around the industry for a long time. I started out in the concrete world. I've done everything there is in the concrete business except sell cement. My favorite customer at the time was a client called DYK. They built pre-stressed concrete tanks, and I eventually got the opportunity to go to work for them. And I traveled the Western U.S. pretty heavily. And my job not only was to basically help market tanks, but because of my background, I got to turn around and basically repair anything they needed, because there just wasn't anybody out there that had a background in concrete and how to repair these structures. That once you go and put a patch on or something like that, once you start putting these things under hydraulic pressure, a lot of things just don't last. So my job was to turn around and make sure that concrete tanks look good. Well, lo and behold, we had us a recession, and eventually the company they merged. Became DN Tanks, and I worked for them for a few years, and then the recession kicked in, and it just looked like a lot of cuts going on across the board. So I jumped ship and I went over to a company called Paso Robles Tank, which is actually probably the largest steel tank builder in the Western United States. And I learned so much about the steel tank business in 4 years that I probably got the best rounded education when it comes to water tanks, period. So I've kind of reached a big milestone here this last year. I turned 60, and I just turned around and felt that, and I have so much to offer that I don't know if I want to turn around and keep up the fight of steel versus concrete. A friend of mine has been a long time, well, he's been in business for 8 years with Blue Locker, and he's just an excellent diver. And I've used to see him at trade shows, and I really loved picking this guy's brain. And I got to know so many divers, and I thought, you know what? I could do something here. So my wife and I bought half the company, and I want to take the report writing for tanks to a whole different level. I want to do inspections at a whole different level. So far, the clients that we've had for the 5 months that I've been on really seem to like what we're doing. And so one of the things that I've always done is speak at trade shows on whatever topic I felt I was qualified to talk on. So this presentation that I wrote, you guys are the first ones to get to hear it. The do's and don'ts of maintaining water tanks. So my email and phone number are there. So if you have any additional questions, if you guys ever have questions on tanks at all, not even if it involves cleaning tanks or anything like that. But if you have questions on tanks, I will steer you to the right place. I can take care of you. So with that, let's go ahead and get on to the presentation. And why isn't it not forwarding? Hang on. There we go. So who we are, this is the advertisement section, guys. So you're gonna have to sit down for this one. We're a fully insured, full service dive team for your potable water service needs. You don't have to take the tanks out of service. That's a big thing to a lot of places. We do salvage. All divers are from a professional diving school for surface supply diving. We do not have guys that scuba dive to go in there. This is, these are professional guys. We strive to offer the best evaluations and competitive pricing throughout the industry. And as I just said, we strive to write the best reports in the industry. I also have done several reports written to support FEMA grants. FEMA has got programs out there to basically, there's three main funds. If you have issues with seismic, flooding, or seismic, flood, and one other, and I can't think of what it is. There are funds for these. Well, your tanks end up meeting all the criteria. So I've had the opportunity on quite a few occasions to go out, look at a project, write the report, and then they turn it over to a guy that there's a guy in Arizona named Gary Sturdivant, a very sharp guy that he was the first one I ever worked with on this. And I had a project I got called out on. It was a old Pritzker tank. Now, most people probably don't know what a Pritzker tank is, but it's probably the largest failure of a concrete tank in the history of water tanks. There was a 6 million gallon Pritzker tank in Westminster, California. And the way this tank was built, it had a concrete slab with a trough at the base. And they were precasted fluted panels. And they basically would just put them up in place, then put the roof on, which was also a kind of a T-beam construction. And then they wrapped a pre-stressing beam on the bottom and the top. So think of it as like a big concrete whiskey barrel. And eventually this tank started leaking a little bit. So they dropped the volume down from 6 million down to 5 million. And what they didn't do is pay attention to all the cracking that was going on in the lower curb that was holding the post tensioning, and water was able to get in there, started the corrosion thing, and then basically at the wedges, when that failed, basically these 20-foot tall precast wall units broke into basically like 6-foot surfboards of death, riding on a 5 million gallon wave after the tank was topped off in actually it was late 1990. It was 99 or 2000. I can't remember which year, but it was one of those 2 years. But it basically, that 5 million gallon wave with these broken pieces of concrete wall went through an apartment building and a fire station and just totally wiped it out. I actually do have those pictures in a different presentation, and it was bad. So I got called out to a place in LA to go look at a tank, and I was honest with the guy. I said, "Hey, listen, I'm leaving for Europe tomorrow. I'll be back in 2 weeks. We have to go out and look at your tank, do whatever you need." And he goes, yeah, no problem. He goes, I was told it's a Pritzker tank. And I was like, you got to be kidding me. There was only about 30 known Pritzker tanks, and I thought I had found them all. And I said, I'll be there in 2 hours. I was in Bakersfield at the time, coming back to my house. And so I called my wife, told her, hey, start packing for me. I'm going to be home late. So I got out there. I looked at this Pritzker tank. Not only was it a Pritzker tank, but it was a square tank, which you'll understand that when in another slide, when we talk about where's all the tension on these tanks, so it was a square Pritzker tank, and it was sitting on the elementary school playground. If this thing ever broke, it was going to be the biggest disaster ever. And so that night I sat down, wrote the report, sent it to this guy, and I'll never forget, I wrote at the bottom of it, I said, number one, I would not recommend putting water in this tank without a structural engineer signing off on it. I said, my biggest fear is that something is going to happen here and we're on the 5 o'clock news. And they took that report and they gave it to this gentleman named Gary Sturdivant, and Gary works on getting FEMA grants. So he took this, and it was probably a 2 to 3 year deal where he took that through and he got FEMA money. FEMA's got the grant money for, like I said, for seismic, fire, and flood. Fire was the one I forgot. And they basically, FEMA had said that their ultimate liability here was like $300 million. So what they did was they gave the district $3 million grant to do away with the problem. And so this year they're now getting rid of the tank and they're replacing it with 2 smaller steel tanks. All right, so let's go ahead and move on. So service descriptions, we do thorough cleaning, inspection, we do salvage, spot repairs, valve services, leak detection. All work is documented and approved by OSHA, SPC, and AWWA. So into the presentation now. The tank, anytime you have your tanks assessed, it should include an interior evaluation, an exterior evaluation, coatings, signs of structural issues, water quality issues. That's something you'll never see in anybody's reports except probably ours. You want a detailed report, video, and pictures. So AWWA recommends sediment removal at 1/2 inch. Now, that sounds fine and good if you're buying water from a source that's already given you a clean water. I can see those tanks as the recommended service every 3 to 5 years. I've seen tanks that can go 10 years when they're buying water from somebody else, and because the tanks just stay clean, but they should still be evaluated every 5 years. If you are on a well, it just depends on the well. I have seen some wells that will put a couple feet of soil in your tank every other year. So if you're on a well, you should be on a program to where you, based on how much sand or even iron and manganese you're getting in your water, you might need to speed it up to take care of things. It's like these, whenever you get too much sediment in your tank over 1/2 inch, this now becomes a breeding ground, and this is where all the bad things can happen. The biofilm, bacteria, it leads to salmonella, E. coli, meningitis, all kinds of stuff. So let's go ahead and move on. Drinking water problems, iron and manganese. The first time I ever encountered manganese, I was on a trip for DN Tanks up to Missoula, Montana. And there was this little water district there that was going to turn around and have a new tank built. And so I'm in my hotel room and I found the bottom of the sink, the bottom of the toilet, basically anything that had water staining. Basically, it was like stained almost like a reddish brown. And it was really disgusting. And it took me a while to think that, well, if this is what everybody's sinks are looking like, I wonder what their tank looks like. And so I'd actually asked the question of the guy later on and asked him, how often do you clean your tanks? He goes, oh, we're very religious about it, every 5 years. Well, looking back, I think they should have been doing things a little bit more often. More recently, I just ran into black manganese. I didn't even know black manganese existed. After I dealt with this issue and it had to write a report. I had to do something on the water quality. And the more I learned about black manganese, this stuff is a real nightmare. And this is, you guys are AZ Water, where this one was encountered was basically right on the border of Arizona and California, but it was on the California side. And black manganese is more prevalent whenever you have a shallower well, and so the manganese comes up and it interacts with your disinfectant, and it just does some harmful. Apparently it does not harm the quality of your drinking water. It just makes it black. And the guy that had us out there to clean the tanks, we cleaned 2 feet of manganese out of this tank, and they just had their tank cleaned 3 years ago. Our suits had to be totally disinfected and cleaned out right on the spot. It was pretty bad. But so it was really interesting. But the one thing, if you look on the slide in the lower right-hand corner, you see that pipe. This is what the manganese does. It actually starts building up in the pipes, so it starts causing flow issues. It's going to cause issues with how your tanks operate, but more importantly, how your water is delivered to the house. You could clean the tank all you want, stand up on top of it, your piping is going to get the worst of it. So let's go ahead and move on. So what water is being sampled? This gets into another water quality issue. Everybody knows about stratification, and I've sat in enough presentation on mixers that I believe in it. I'm going to tell a story about the first time I ever really did a full study on an issue of what water is being sampled. I was in Colorado. There was a 9 million gallon hopper bottom tank, and they were having issues with leakage and all kinds of stuff. So they drained a 9 million gallon tank for me to come in there and do a complete inspection. And the interesting thing is, when I was in there, I started noticing all this white powder on the floor. So because I don't get to stand in front of you. This 9 million gallon tank was a large rectangular tank. It was probably about 250 foot long on one axis and probably about 150 feet the other way. And it had one common inlet outlet in the middle of the short wall on one end. So as you picture me down towards the inlet outlet, I found very little of this white residual on the floor. But as I started walking away, think of it as like a half-court basketball court. As I'm walking up the key to more like the three-point line, outside of the three-point line, all of a sudden I start to see all this white powder everywhere. And it started getting worse and worse. As I got to the far end, it was literally about a ½ inch thick. So I figured it had to be the disinfectant. Something's going on here. I don't know why this stuff is just sitting in a powder form. So I scooped up a big handful of it and I stuck it up to my nose and took a big whiff, and I couldn't smell a thing. And so they took the sample and they had it tested, and they said, yes, it is disinfectant, but it's innocuous. So what the owner did was an amazing project. They put a diver in the tank, and they did everything by grid. They started out closest to the inlet outlet and started out one wall, and they'd call it section 1, level 1. So the diver would go down to the very bottom in the left-hand corner, and he would get a sample about 1 foot off the floor. They would then draw about 10 gallons of water out, and they would capture a sample in a jar, and they would write on it zone 1, level 1. Then the diver would move up about 10 feet, and they would do the same thing, capture it again, and then they would go up towards the surface and capture it. So they were getting 3 tests, and then he would move down about 20 yards, and then they would do it again. So they were doing a grid. They must have had 500 samples in this thing. So they took it back to their lab, and whenever the lab guy had time, this was his project, was to turn around and test each of these samples and do recordings for residual level. And so by the time they were done, this looked exactly like once again, like an NBA half court. And the residual level from like the free throw line to the outlet, everything looked great. It was fantastic. Once you started getting to the far reaches where the 3-point line would be, all of a sudden there was very little residual in the tank. And then as you worked out past the 3-point line, it was zero residual all the way to the back wall. Matter of fact, they stopped doing the test because the results were just, once you got past the once you got past the 3-point line, there just was nothing there. So what they found was that, obviously the last water in is always usually your first water out. There was no mixing going on. So they were able to turn around and put a couple of mixers into that tank. And basically they brought up the residuals across the board. The one big thing that it got rid of, and this is for all the owners and especially the consultants that are talking to the owners, the one thing that happens, especially in the summer, it's called spiking. Whenever they start getting a low residual level, they will go over, open up the hatch, and just dump the disinfectant into the top and try to spike the results. Well, that might work for up front, but all it did was it wouldn't, the water wasn't moving enough to basically mix it up. So so that's the Colorado story. One of the next ones. So after I've learned all this and I've talked to people, and said, mixing is a great thing. When I was out in Utah, and one of our reps brought me along, and I'm looking at one of their tanks. I'm going, God, a nice looking tank and things like that. So how often are you turning it over at this time of year? Because it was kind of a resort area. And he goes, well, in the winter, we're turning that thing over every day. He goes, spring and fall, probably once every 4 days. So I'm asking him, I said, okay, so what are you doing about the water that's sitting there stagnant during the low periods? I said, are you testing the different areas? Goes, no, just the exit. And that's right where we we have our disinfectant injected there. I said, well, what about the rest of the water? Don't you test that? And he goes, no, we don't want to know. Usually I despise bottled water. I'm a big advocate for trying out everybody. Making water is almost like wine in my world. And that's probably the first time I ever insisted on buying bottled water, because this guy just didn't give a damn about water quality. So where everything is being sampled doesn't always mean what's the rest of the tank. So, all right, so cleaning the tanks, ROVs versus divers. Now, our company used to own an ROV, and a lot of people are buying them now, and they're really pushing them around the industry. ROVs they can get in there and take some nice pictures. They really do. The problem is when you use them to clean, the ones that can scoot around the tank and take the pictures, they're usually on like fan blades. So when you start getting them down to the bottom, all they're doing is kicking up all the dirt. So by the time they're done doing their thing, the tank looks great. If you go back and look at it about a week to 2 weeks later, you're going to see all the sediment settle right back down. The ROVs just do not do a good job of cleaning. Not to mention they can't find leaks. They can't make repairs. They're always getting stuck. When I was saying that we do salvage, we just salvaged an ROV here in Las Vegas area for somebody that basically got it wrapped around the umbilical got wrapped around one of the pipes in the tank. So, like I said, they're always getting stuck and you can't get them out. So, understanding, let's get into concrete tanks just a little bit. I want to talk about understanding the design of concrete tanks. Now, I know in Arizona, concrete tanks are not as prevalent as steel. We'll get into steel next, but I want to touch on concrete just a little bit. First thing that's important is you got to understand, is your tank a free base or fixed base connection? So you need to know how each will handle the load. A fixed base connection basically means that your tank floor is connected to the wall by rebar, so that when you fill that tank, that wall is basically locked in place and it's not going to move. That's probably how about 80% of concrete tanks are built. The other is a free base connection where the wall is not tied to the floor. It sits on a rubber bearing pad to allow it to move freely. That's more of a tank. I'll just go ahead and say that's a DN tank or an old DYK tank. It's called a pre-stress tank, and how they'll handle it. One question I got hit with, and I use it in the presentation a lot, and this question was by a guy that was in the steel tank industry. And he said, he goes, okay, if concrete tanks are so great, why don't I see a lot of concrete tanks over 100 years old? Well, there is actually, up in the Bay Area, there's quite a few tanks that I've seen that are over 100 years old. They're, concrete basins, things like that. But the predominant use of concrete did not come around until the 1940s. When you think about what delivering concrete is like, you need to have a truck capable of a large truck big enough to haul a truck that's got a turning mixer on it. So those types of that type of equipment didn't come around till the 40s. So when you start seeing some of those tanks that are from the 40s, a lot of them were built by Ed and Earl with a pile of rock, a pile of sand, and bags of cement. It was 3 scoops of rock, 2 scoops of sand, 1 scoop of cement, and then they basically put it into the forms and used a stick to move it. So a lot of these old tanks need to be looked at with an eye other than, oh yeah, the tank looks good, I didn't see anything here. Yeah. It's like you need to have these things evaluated in a different way. The advantages to a concrete tank is they are a long-term solution, especially if you can keep them in compression. When I worked in the concrete industry, I worked for a company called Master Builders. We were the companies that invented all the admixes that go into the concrete, things to make concrete either not shrink, all kinds of good stuff. So the one thing that they taught me there, day one, that if you can keep concrete in compression, no one knows how long it will last. By the way, somebody's voices coming in over this, so make sure you're muted. The second thing is it's a very low maintenance structure. The disadvantage to concrete is the upfront cost is definitely the highest. You need specialist inspections, and concrete tanks do leak. The predominant reason for leakage is usually what the water stop technology was back in the days. When I go out and do an inspection on a concrete tank, I usually want to look at the drawings because I want to know what the water stop looked like that was done in the joint, because that's where the leaks are typically going to have, because you're supposed to replace the caulking every 20, 25 years, but nobody ever does. And once that caulking loses it, now you're the victim of what the water stop was like. So we were talking about how each tanks handle the load. So in the slide here, I don't know if you can see the arrow that I'm moving on, but so this triangular distribution represents the load on the wall. So think about it. If you jump into the tank and go down to the bottom, just like in a swimming pool, if you're down here, your ears are going to feel pressure. Well, that's because of the hydrostatic load. So this load is going to be on the interface of the concrete wall. Concrete loves compression, hates tension. The inside of that wall is under 100% compression, which it loves. The other side of the wall, however, is under tension and it doesn't like to bend. So if your concrete tank is a fixed connection, meaning you had rebar coming from the floor into the wall into the roof, basically that wall's got to bend. And concrete is not a flexible thing. So typically what you're going to find on smaller wall tanks, you're going to have one good crack about halfway up. And that's what we call the bending moment. On taller tanks, you're going to have a crack about 1/3 up and about 2/3 up. If that doesn't make sense, hopefully you guys have got my email or my phone number, and I can fully explain it further. So this is a free connection tank. This is a pre-stressed tank. Out in your area, your DN tank rep is a guy named Sean Siddall, who is absolutely a really sharp dude. And so here's that same triangular distribution load on the interface of the wall. But what they're going to do is they're going to counteract that bursting force on this wall with a higher force of pre-stressing. They're going to use high strength strand or wire to counteract the bursting force here, plus give it enough extra residual force so that you're going to get 200 PSI residual compression into the wall. So this wall moves in and out on this rubber bearing pad that it sits on top and bottom. So the wall moves independent of the floor and the roof. So let's get into steel tanks. Steel tanks advantages. They're designed for a long life as the tank can be recoated. Now, I am talking about welded tanks, not bolted. Let's talk about welded first. So a welded steel tank is a really good investment because the owners can basically sandblast, recoat, and it's like getting a new tank every time they do it. The cost to build a welded steel tank is moderate compared to the other options. Concrete, more expensive. Welded is right in the middle, and then bolted is the cheapest. This is a complete leak-free design. AWWA standards for welded steel tanks call for it to be leak-free. So the disadvantages of the welded steel tank is, number one, it must be maintained. If you are falling behind on maintenance, and this is, I will say this, if you have a steel tank and you're not maintaining it, you're going to see it. When you have a concrete tank and you're not maintaining it, you're not going to see it. Only an expert will be able to see it, what kind of damages you're doing and what needs to be rectified. Most of these tanks, and I would say about 95% of the tanks, are built to a minimum AWWA standard. So, and let me explain what the AWWA standards are. When the standards committee first started coming around, and honestly, I don't know the year, so I don't want to spout something off, but somebody told me that it was back in the 70s is when the first AWWA standard committee started being formed. If I'm wrong, somebody please text me or email me and let me know that. But the committees back then were actually loaded, and they always are loaded, with guys that are heavily involved in the steel tank business. One of the main attributes of the committee is to basically set the minimum standards. Well, the main objective of a lot of people that work in the steel industry is to basically make sure that on day one, a steel tank is going to be the lowest cost to the owner. You know, it used to be nobody looked at life costs. It was always day one cost. So they wanted to make sure that a steel tank was always going to be the lowest day one cost. Elevated steel tanks, advantage, gravity fed. Past that, I can't think of any. Disadvantages, the rehabs are absolutely expensive. And the companies that are willing to do the rehabs, there's so few that are qualified to do this that they make a boatload of money on the rehabs. Also, I've been up on some of these tanks, and I'm telling you right now, it is a scary deal. But so the cost of rehab is one of them. Seismic issues is another. Anybody that's put one of these tanks in, especially a high seismic area like the West Coast, has got to have their head examined. So we're looking at this tank right here, and everything looks great, but you know what? This is an area that has suffered a few earthquakes. So this is the footing that we find on a lot of these types of tanks. And when you look at this footing, you'll see all the structural damage to the concrete. When concrete is broken up like this and almost looks shattered, it completely is. So what's going on now underneath that no engineer has caught yet, or anybody has caught yet and made mention of, until you get somebody that actually understands concrete and steel and water and hydraulics. And what you find now is that underneath here, all that rebar that's holding those bolts down are just being rusted away. At some point, this thing is going to completely collapse. There needs to be a structural. When we did our evaluation here, I basically wrote in that this requires a structural evaluation to further look at these footings. Because number one, this tank was built back in the 60s, I believe. It has never been upgraded to code. And that's a big thing right now. One thing when we talk about seismic codes, the codes have changed almost every time they've done it. What we're finding is that the earth is changing quite a bit. Mother Nature is very angry. We also probably have better equipment and technology today to understand things. One of the most interesting things that people don't realize is that we have higher ground accelerations for uplift along the foothills in Southern California than there are in the Bay Area. Everybody thinks the Bay Area is going to be the worst spot. Not at all. It's going to be probably along the foothills. And when you look at all these old tanks that were put in the ground probably by farmers because there were water in their field, and then when the Clean Water Act came along, they sold these tanks to other places, and they just put a roof on the tank and left it as it is. It's like when these things start to go, it is going to be a disaster upon disaster. And when you talk to the guys, go, what happens when this thing goes? Oh, we have an agreement with the guys next door to us to help provide water. They've got the exact same stuff you've got. So you guys are all going to be in trouble at the same time. Okay, let's get on to bolted steel tanks. Bolted steel tanks, they have a place in the industry. They are a very low-cost alternative. If you are looking at a very small tank to an area that just doesn't, turn a lot of water, things like that, or if they are looking for a shorter life, 20, 25 years. And I say that because a lot of people will look at, I just looked at a bolted tank the other day that was 70 years old. But the standards for these tanks have changed. When you look at a tank that was built 70 years ago, that steel was twice the thickness of what it is today. It isn't as flexible as the steel today. These tanks today are built to keep the cost down, to basically provide the customer with a low cost niche. If you're looking for something for 20 years, great idea. The coatings they're putting on these tanks now, they're baking on a powder coating and the outside. So it's like they're very low maintenance. When it starts coming time to redo these things, you got to really take a look at the cost difference between just getting another one, because if these tanks have had a lot of sloshing in it and things like that, you really need to check to see how much the bottom 6 feet of that tank has started to bow. If it started to bow, it's time to get rid of that tank. All right. It was built to very minimal standards, and the erection of these tanks, they go up very fast. They're not leak free. Every time they look great for a while, but then they start to leak, which probably gets me into this one. This is a tank that we just repaired. And when I say repaired, I'm going to say we put a Band-Aid on it. This is, 350 to 400 gallons a minute of a leak coming out of this tank. And they the problem they had was they want to get a new tank, but with the engineering required and all that stuff, they needed to buy themselves 6 months. And we basically turned around and said, okay, we're going to try something, but there's no guarantees here. And this was, oh, I'm sorry, let me advance that. All right, so this is what was done after our guys were in. We had this thing down to a gallon a minute, and the leak that you see is not coming from the repaired area. It's actually traveling along about half the tank. Everything was so corroded on the bottom that basically all the caulking failed. So everything is traveling to the point of least resistance, and that's where all the leakage is coming out now. So I actually check in with the guy about every month just to see how this is going and how they've got a good engineer on board, and they're going to have that tank replaced here in probably about 3 months. So it's a good feat of engineering. So what the engineering community should know about steel tanks and how to reduce life cycle costs. So first of all, how long should coatings last? Rather than me tell you how long it's lasts, I'm going to refer you to a paper written in San Antonio, Texas in 2014. And this was a corrosion seminar by SSPC and NACE. And these guys got together and they wrote a paper on steel coatings. And what they're saying is that the practical life is considered to be the time until 5 to 10% of the coating breakdown occurs and acting rusting of the substrate is present. So as you're sitting in your offices, I want you to imagine that you're in a tank. And as you're looking at the roof, if you see 5 to 10% of corrosion all in one isolated area, that can be repaired. They can do it. If it's really bad, they can come in and cut it out, put in new plates, weld them in, coat it, and things like that. But if you've got 5 to 10% across your entire roof, then it's time to recoat the entire system. So what that involves is original painting year one. You want to do a spot touch up and repair at 15 years. This is on the interior. One thing to remember, interior coatings are very expensive. Exterior coatings are cheap. It's just paint. So you want to do a maintenance repaint and full coat at year 25 to 30, and then a complete recoat at 35 years. On the interior, or I'm sorry, the exterior, your original paint year one, you want to do a spot and touch up every 5 years. So you want the owner to just send their operators out around their tanks, and they start seeing things. Do a spot touch up, and basically take a wire brush off the dead paint, put some good paint on it every 5 years, and then do a pressure wash and overcoat at year 16. On a welded steel tank, you want to keep the paint with a shine that reflects all of the rays that cause the bad things. But if you stay on top of your top coat, you may never have to strip the original coatings. I've looked at steel tanks where I've seen 5 layers of paint coatings. But the largest issues with steel tanks is corrosion above the water line in the vapor space. So when you go into a tank, 99 out of 100 times, you are going to find all your corrosion above the water line in the rafters and the roof. And here is why. So this slide that purple arrow you're looking at points at one black spot. When we talk about the AWWA minimum standards, this is part of it right here. As part of the minimum standards on building a welded steel tank, that is the only weld that is required for your entire roofing system. So when you start, hopefully you can see the arrow, but you can see right here, the overlap right here. That's where corrosion is going to breed. Everywhere the steel touches steel, as we look at this one, we're pointing at all the areas where corrosion is going to just bloom. And what we want to call this are the unpaintable areas. So here is a roof, and you can see the corrosion blooming out from all those unpaintable areas, except for one spot. In the underside of the roof plates, you can see the gray. The gray represents that they seal welded it. This is one of the ways that you can eliminate corrosion inside steel tanks, is by completely seal welding the tank. But they did not seal weld the rafters to the roof. So this is where it's going to breed. The roof straps is where it's going to breed. As we get into the next one, now you can see the overlap of the roof plates. This was on a 1-year inspection. You can see that basically all the corrosion just breeding out from underneath the rafters and underneath the roof plates. So how do we fix that? Well, how do we fix this? The industry has changed quite a lot. They've realized that one of the biggest issues in this business is who's painting the tanks. So the industry has gotten together and they basically come up with a standard to fix the steel tank industry. And they came up with QP certification, and what it stands for is quality painting. QP1 certification, and there's a lot of steps to become QP certified. You've had to have painted so many environmental structures. You actually even have to show your financials to show that you are viable. One of the most important things you can do on top of, well, let me finish the QP and then I'll finish it. But QP1 complex structures, that's like water tanks. If you've got a rehab coming up, you want QP2. These are people that are trained in how to handle lead, asbestos, all kinds of things. QP3 is another important one, but it will eliminate a lot of competition when it comes time to bid a tank. QP3 is how the plates are manufactured at the plant. So typically the plates are rolled to the specification, and then they're basically blasted and painted, and then how they're shipped. So under the QP guidelines, the shop has to have a certification. Only maybe about half the shops that make these tanks are QP3 certified. So for the engineers that are out there specifying things, I've actually got a set of specs that I've used for years. If you're looking for anything for, you want a great spec for new tanks and the coatings, I've got a spec for it. If you're looking, and then the coating can be used for the rehab. So earlier I talked about AWWA equals minimum requirements. This I'm going to read to you straight out of their guidebook. AWWA standards are consensus-based standards representing the minimum requirements considered necessary for a product to provide satisfactory service in the water industry. These standards do not necessarily represent best practice. The AWWA standards are intended to be supplemented by project specifications when a purchaser or specifier desires to exceed the minimum requirement. So we're going to talk next about some of the things that you should upgrade. The AWWA coating standard. Now these guys actually have upgraded their standard a little bit. AWWA D102 provides minimum requirements for surface preparation and coating application for steel storage tanks. Although the minimum requirements of this standard have provided satisfactory surface for many water utilities for many decades, there are certain aspects of tank coating systems that can be improved when special roof construction details are specified that exceed the minimum requirements. So let's go ahead and show you a couple of these. So this is we're looking downward on a welded steel plate, tank roof. So the rectangular plates represent the roof plates. The pie shape represents the rafters underneath. So if you wanted to go in there and do the seal welding all the rafters, the roof, you can see what a labyrinth this is and how much time it's going to add. So now we're going to introduce you the press brake roof. This is where they take the roof plates, instead of bringing them rectangular, they're going to cut them to a pie shape. Then they're going to take one edge, they're going to bend it bend it, and then bend it again. And what that's going to do is create a structural beam now that can support its own weight. The best thing about this is that it allows complete seal welding very easily. Does that make sense? So another advantage of it is that they can take the bends and put them on the roof or put them underneath. If you want it to look traditional, you put the bend side down. If you want to turn around and totally eliminate corrosion, you put them on the bend side up. So what we're looking at on the left are tanks less than 90-foot diameter. They can do it in the pie shape. When the tanks are over 90 foot, they put a couple columns in there with a steel beam and then basically a little more support for a roof that size. I'm going to try to move it a little bit faster. So when you start looking at coating, would anybody argue that this would not only be the cheapest cost to install, but also to maintain? There's no sharp surfaces in there. So what if we actually took this and made it the roof? In the left slide, that's the exact same tank. So you can see there are no unpaintable areas in that roof. There's nowhere for corrosion to bloom. The tank, the picture on the right is a tank less than 90 degrees. You can see how all the pie-shaped pieces came to the center column. Okay. Okay, so I'm going to spend a couple minutes and just talk quick seismic. I know for Arizona, seismic is not as big an issue as it is more towards the west, but I've been doing this slideshow for a long time, and everybody seems to love the seismic slide. So I get known as the seismic. I was at Tri-State one year, the year I did this, and I'd asked if anybody had ever heard of the Cascadia subduction zone, and nobody had. And so what there is a subduction zone off the coast of California, and it goes from Northern California all the way up into Canada. So what you've got is the Juan de Fuca plate and the Pacific plate that have been moving forever. And how this began, it actually started out with a survey done by, it was either University of Oregon or Oregon State, but they went into what they called the dead groves. And they were about 20 miles inland, and these groves were all dead, and they wanted to know why they died. So they cut some of the trees down, looked at the rings, did whatever scientific stuff they do. And what they said that these trees all died in one single event in somewhere in early 1700. And so the second piece was there was always Indian folklore that said that one day the earth shook, the ocean dropped, rose, and took their people into the ocean. So you had that. But the third piece was Japan. Japan has always kept an amazing history. And they said on January 26, 1700, they got hit with a rogue tsunami that wiped out the eastern coast of Japan. Now, one thing about Japan and the United States, when we get major earthquakes there, because of the shape of their shoreline, there's not a, it's such a gradual, like if you've ever been up to like Haystack Rock up in Oregon or out at Galveston, you could walk out into the ocean a quarter mile and still be right up to your waist. Whereas if you walked into the Pacific Ocean, 20 feet in, you're over your head. So it's the shape of the shelf. So when Japan got the 9.0 earthquake back in 2011, they got tsunamis. The United States West Coast just got great waves. The surfers loved it. When we get major earthquakes, they get tsunamis. So it's just the shape of the coastline. So this slide you're looking at is a timeline, and it represents the Cascadia subduction zone. So what the group did was they went out in the ocean, they found this subduction zone as a fault line, and somehow they were able to capture enough material to take them back to 8,000 BC. Now, the thick, long lines represent earthquakes over 9.0 magnitude. So as we go down the list, you can see, the first use of the wheel here about halfway. So, King Tut was born here, birth of Jesus right here, fall of Rome. So you can start looking at this timeline. Basically, every 250 years, this thing is erupted with an earthquake minimum over 8.0. If you look at the gap we're in right now, we are in one of the largest gaps. So this is coming our way, whether we like it or not. If you ever want to read more about this, New York article, the New Yorker magazine. The article is called The Really Big One. It was written July 20th, 2015. And I'm telling you, this article wrecked real estate values along the coast of Oregon and Washington. They had to do a revision that kind of softened things up after all the uproar. But the Cascadia subduction zone is ruptured on average every 250 years between an 8.7 to a 9.2 earthquake. We talked about how they found it. The damage will be felt as far as Sacramento. So they're saying that a 9.0 earthquake is going to shake for probably over 5 minutes. Now, when they compare that to the San Andreas Fault, which they think is going to be the one that ends all, San Andreas Fault is only supposed to get to about a 7.6. So we're talking a lot bigger. Here, for those of you out there that are under 30 years old, you have a 33% chance that this is going to happen in your lifetime. That's one of the only, like I said earlier, I'm 60 years old. Hopefully this doesn't happen in my lifetime. So we're going to show you real quick an analogy of earthquakes in pasta noodles. A magnitude 5 quake will break 1 uncooked pasta noodle. A magnitude 6 quake would have the strength to break 6. A magnitude 7 would break 900. A magnitude 8 quake would break 27,000 uncooked pasta noodles. And if we ever hit a magnitude 9, 810,000 pasta noodles. Japan just went through this in 2011. Here's pictures of the tsunami coming into Japan. The largest earthquake we've had in the United States was Alaska 92. Here's a picture from that. This is a little chilling. Kenneth Murphy, who directs FEMA's Region X, the division responsible for Oregon, Washington, Idaho, and Alaska, says, our operating assumption is everything west of I-5 will be toast. So we're now hitting the 1 hour mark. I'm going to skip this section, but I will show you this. This is what happens inside a tank when an earthquake happens. This is down in Mexico. What you're looking at is a 5.5 magnitude earthquake. And now it's a picture of a swimming pool out at one of the resorts. And in a second here, you're going to watch what water does and this is without a top on it. Imagine if you now restrained it, you didn't have, when we talk about freeboard in a tank, this is exactly why we talk about freeboard. How much sloshing is going to happen? Here it comes. Right there, there's about 4 feet of sloshing right there on a 5.5 magnitude quake. So as I move out of it, now you can see this is what we call elephant footing. This is what happens to steel tanks after earthquakes. This was from sloshing on a freeboard. So I'm going to go ahead and end it there and turn it back to the administrator here to talk about the next month. And if anybody has questions, I'd be happy to answer them. If they'd like to email me, it's mark@bluelockerdiving.com. My cell phone number is 951-501-6935. If anybody out there has got a tank to be cleaned and inspected, I'd love to give you a quote on it. Please look us up. Let's go ahead and turn it over to the moderator.
Thanks, Mark. That was a great enlightenment. Man, that's a lot of information. We should probably split that up into 2 or 3 presentations about concrete.
I would be happy to do it anytime you want.
Get a little bit more detailed because we're all engineers and we like the details. Is there any questions out there? Before we go, doesn't look like it. All right. Next month is Advanced Metering Infrastructure by the Arcadis Group. You can sign up at the same place you registered on the Arizona Water Association Distribution Committee's page. There's a calendar invite. Please register. These have been great webinars and we've all learned a lot. So pass them on to your colleagues and we'll start getting the word around that we're doing this and get the attendance up. So otherwise, Mark, we appreciate it. Everyone that's tuned in today, we appreciate your time and have a great day.
Thank you all.
See you later.
Thank you all. Remember, PDHs will be emailed to you. If you have colleagues that would like PDHs for this, they will be posted on our website where they can be viewed at a later time. And AZ Water can be contacted for coordination of gaining a PDH that way as well. So let your colleagues know and see you all next month.